This media was gratuitously produced by Clear Contributions Audio Video. The intellectual property contained within belongs to Dr. Barbara Van Kyken. Clear Contributions. Let's have clarity.
Okay. So to compare, if you're naming an amide, then first I guess you want to figure out that it is an amide. So you're looking at the carbonyl carbon, not that you have to highlight this in yellow. I'm just trying to direct your attention to what you're looking at. You're looking to what is directly attached to it. And if you have something that is non-hydrogen, non-carbon or anything, then that's going to be an easy way to figure out what class it fits into. So that makes it an amide. So with an amide, the oxygen and nitrogen attached to that carbon are both part of the functional group structure, but I'm not going to include the carbon because that's part of the parent hydrocarbon as well. So that's what you can think of. Should I highlight it both ways or just leave it like this? I don't know. But there's your parent hydrocarbon. The parent hydrocarbon has to include the carbonyl carbon, even though that might not be the longest continuous carbon chain. The rest of these are substituents, so I'm going to fearlessly highlight them green. This is an amide. You have a butyl group, and it's not a sec butyl or a tert butyl or anything because you're attached to the end carbon and there's no branching in there. And then you also have a propyl group, same thing, it doesn't have any branching, so it's just plain propyl. Or sometimes you might occasionally see N-propyl. You put your substituents in alphabetical order, so that'd be butyl propyl. And then either the name for the carboxylic acid in IUPAC that's derived from, or for the 2-carbon parent hydrocarbon unit, you can let me know on Friday or Monday after you've practiced with it a little bit, what you like. So either put ethane and cross off the E, or put ethanoic and cross off the ic. And we will settle into one pattern or the other really soon so that I'm not confusing you by doing it 2 ways much longer. Okay, and then the ending for it is amide. Say if you have more than one of anything, you don't. Then say where everything's located. This time, since a nitrogen could have 0, 1, or 2 things attached to it, now you use N to describe what is there, because otherwise, The
ethanoic and the ethane. The ethanoic has an O, and the ethane does not have an O. Mm-hmm.
So I was going to bring that one up. This is one of the cases where you would cross off the oic acid because you'd have ethanamide either way. And so I guess that's the other thing that would go in favor of not naming it as the carboxylic acid, because sometimes you cross off the oic acid and sometimes you cross off the ic acid.
Oh.
As I said, if you goof up and leave an O in there that isn't there, I'll just laugh at you. I won't mark you off. Okay, so both of those are attached to nitrogen, so you say that by putting an N out front. And butyl and propyl ethanamide.
Why did we cross out the oic one more time? Is it the amide?
Because the IUPAC, people just want to make your life miserable so that you never know if there's an O there or not.
Oh.
And then that makes them sound intelligent. It's kind of like if you tell people that you're from Buena Vista, they know that you're not from this area.
Oh, okay, that's right.
You know, this is their little club.
Yeah.
Yeah, if you leave an O in there, then you're not part of their club. I don't know.
Wouldn't believe the chap. He left the O in it. Rookie mistake.
Okay, so esters are the only ones where you are putting something out right in front just to designate everything, and otherwise you would just alphabetize all the substituents always, every other case. So I think that I need to put in your directions, maybe your final directions, that if you have an ester, that would go out front to help you remember. I've been going through and scribbling through here and trying to improve it, so. Okay, so let's see. I have a homework assignment for you. It's 2 pages. I think we'll just do 1 page for tomorrow and 1 page for Monday. And I'm afraid that I didn't do this in my chemistry drawing program. I just typed it, and so the bonds look a little bit funny. Hopefully you can interpret it anyway. But these are all the types of groups you should be able to name now. Carboxylic acids, you should be able to name right off, and then acyl halides, anhydrides. And I think that that is pretty much it in this section. Acyl halides, it's OIL or IL for the ending. And the anhydrides, just write anhydride after you've written the name for the 2 carboxylic acids. Everybody get this okay?
Yes.
Okay, I want to just show you anhydrides using an example from the homework. Since I looked, and I don't think I have an example in your workbook chapter. So I'll do the first one on the 2nd page with you so that you have seen anhydrides worked through. An anhydride is where you have an oxygen attached to a carbonyl-carbon. So you have your carbonyl-carbon that you're looking at, and you have the oxygen. And anytime you have an oxygen, you have to look beyond it to see what kind of group it is, because you could have carboxylic acids, esters, or an anhydride. This one, you have a carbonyl group attached to the oxygen, and so that's making it the anhydride. The parent hydrocarbon includes the carbonyl-carbon on each side. This one is the only example where you have 2 parent hydrocarbons, because it looks a lot like you've taken 2 carboxylic acids and attached them together, so neither carboxylic acid is considered to be better than the other for purposes of naming. Plus, I'd love to see you come up with a substituent or functional group name for the mess that's left over if you only pick one side or the other. So we'll start out by doing IUPAC. If you have 1 carbon, that's methane. And if you have 3 carbons, that's propane. But these are both carboxylic acid derivatives, and so you drop the input oic acid. So you have methanoic and propanoic acids. These aren't carboxylic acids, though, so you can drop the acid part of it. You have methanoic and propanoic. Put them in alphabetical order. And then put anhydride. Ta-da! You're going to love those. Right? They're not too tricky.
So when do we change it to oic and ick?
So OIC is IUPAC. And IC is common name, but you're going to be memorizing the whole name there, so
Gotcha. Sounds good.
you'll just know it. I guess caproic is the example of common name where it doesn't quite follow that rule. So, all right. Then common name. Any of you know the common name for one carbon yet? Formic. Okay. I see you guys looking. That's fair enough. At this stage, that's more than fair enough. I'm glad you're even putting the effort into learning them. And then if you have 3 carbons, it's propionic. Put those in alphabetical order and write anhydride at the end of it.
So the fact that it says ionic, is that just coincidental or are they trying to tell us something?
I don't know, but I don't think it's... who knows what anybody was thinking? This is like those questions we were talking about where you're asking what was the author thinking. I don't know. No guess. But that might help you memorize it now that you've noticed that. So I'm good with this idea that it means something very important.
So remember it.
So formic, propanoic, anhydride is the
Propionic.
propionic.
Yep, that's the problem between IUPAC and common name. The name sounds similar, so you know it's 3 carbons and it's easy to memorize, but it's also easy to get them confused because they sound so similar.
That would be common name or
Common name is propionic. Because notice that the IUPAC, you write propane and then put oic. Okay, so now I think you've seen the acyl halides, you've seen the anhydrides, you've seen the carboxylic acids. All good. And you know how to number or write the Greek letters to figure out locations. Yep, I think you're good. F might make you feel like you don't know what you're doing, but just think through it real logically. Figure out your substituent. You can get that. Any other questions about your homework assignment before I just keep dumping more on you? Okay then. We're going to get into some of the special cases. They're special. We'll do lactones and lactams today. We might start venturing into the dark territory of aldehydes and ketones. We'll see. Okay, a lactone or lactam. Lactone is a cyclic ester and a lactam is a cyclic amide. You have a carbonyl carbon with an oxygen or a nitrogen directly attached to it, but the R groups, the carbons, don't just extend off in either side. They actually form into a ring. There are IUPAC rules for naming lactones and lactams, but they're so much less commonly used. Almost every organic chemistry textbook just teaches you the common name method of doing it because people don't really use the other method much. So I figured to help keep your sanity, I would just stick to the common name for this as well. So to name lactone or lactam, I'll use the example down below to kind of talk you through it, and then we can put it into words, but I figure it's always better if you see it first. To name it, so you've got the functional group. I'll go back to here. You got your functional group is that part. And then you have the R group extending beyond it, and that's telling you that it's a type of an ester. So what you do is you mentally break the bond right here between the oxygen and the non-carbonyl carbon. And then you look at what's left over. So if I was to draw this out with that bond missing, what does that look like to you, kind of? Besides like a snake or a question mark or something. No, I'm asking what functional group kind of thing it looks like.
That's just a carbonyl.
Yeah, it looks sort of like a carboxylic acid, right? So you name it like that, and you give it the common name for that carboxylic acid if you mentally break that bond. So this has 1, 2, 3, 4, 5 carbons in it. Do you remember the common name for the valeric? Okay. And then we'll talk about the endings in a minute. No, let's talk about the endings now. Fine. So the functional group ending for a lactone is lactone. Because you're looking at that ring thing and you're going, oh, lactone. And if it's a lactam, it's lactam. So just like before, you're dropping off the ic ending and putting the functional group ending in there. And notice that the atom that is in the lactone, and just in case you're having a hard time remembering the difference between a lactone and a lactam, a lactone has an O, where a lactam is kind of like an amide, lactam. So that part's fine. Now the last thing that you need to figure out how to describe to somebody is where it's attached. So coming back here, you see I tried to make this so that it's like, okay, we're going to ignore that for the moment. So I probably should switch those two, but I digress. Since this is common name, you're describing everything based on Greek letters, and you start the carbon after the carbonyl carbon. So this is alpha, beta, gamma, and the delta carbon. You say that it's attached in a ring through the gamma carbon. So you put gamma valerolactone. You're going to see this, by the way, when you talk about penicillin, for instance, in pharmacology, and they talk about how it has a strained beta-lactam ring. And it fits that into the category of pharmaceuticals or antibiotics known as the beta-lactams.
So I'm very confused. Why is it gamete valeric? So what is valeric stand for again? I guess I should ask.
5 carbon,
5 carbon, okay.
carboxylic acid in common name.
Okay, then why did we put the gamete in front of it? Is that gamete? Yeah.
Here, I'll show you. Well, I'll show you down here, I guess. No, I won't show you down there. I'll show you right here. you could alternatively have that you'd have to name, and if you mentally broke this connection between the oxygen and the carbon that's closing the ring, then you'd have 1, 2, 3, 4, 5 carbons still. It's still a lactone, but they're different compounds. So this one, you would say that it's attached through the delta carbon,
Oh, okay. So
and that'd be
you're
a
saying
delta
which one's attached to
valerolactone.
from. Okay, that makes more sense.
All right, so if you're going to name it, and you don't even have to break the bond. This is just me kind of teaching you early on how it works out, but looks like I needed to give you more space. All right, so you're just counting number of carbons that are continuous there. Name it as though it's the common name for that is a carboxylic acid, and then just say what carbon you're attaching things through, in addition to the ending. Okay, so there you go. Give it a try with the lactams. Similar process, so shouldn't be too much of a stretch here.
So the difference between a lactone and a lactam is the lactam has a nitrogen in it.
That's right, because it's an amide derivative. Excellent. So it's an amide. You notice that functional group. You can still highlight it the same as you did before. Your basis that you're building off of is the longest continuous blue carbon chain that you're tracing through. That's the carboxylic acid that it's based off of, since this is common name. So this time it's got 6 carbons, so it's caproic acid. Then you write substituents, the basis, and then the functional group ending. So you're tacking on O-lactam. If you're wondering why, if you're bitter because I've crossed out the oic acid completely, you don't have 2 O's next to each other. So that one's easy to explain why you're doing that one. And then, because there really is a bond there, even though you're temporarily ignoring it, then just go through, letter everything, and say what carbon you're closing the ring with. Same process, it just looks scary because it's cyclic compounds, and I know that you people have like this dreaded irrational fear of cyclic compounds, like they come and get you in your nightmares or something.
Is it irrational?
No.
So for this unit, we're not going to need to know past 6, correct?
Correct. In biochemistry, then you get palmitic and steric and oleic and all those. But okay, here's some more flashcard stuff, and I put it on the Quizlet app for you. There are 2 specific common names for ketones, and then there's a system for naming other kinds of ketones using common name nomenclature. But these are so widely used that you'll want to know this generic name. It's somebody just looking at something and saying, oh, look, that's named Bob. This is the deal right here. Whoop. This is acetone. It's the simplest ketone you can have because you couldn't have any fewer carbons and still have it be a ketone. And the one next to it is named as though you have acetone and you've put a 2-carbon acetyl group on there. So anyway, this is acetyl acetone, or sometimes you'll see acetoacetone. Just learn them. I was going to circle them. I probably should have done it the other way so that it matches the name below it. There you go.
For something that we're always like talked about, like we talk about it, it's kind of like getting phonetically.
If you what?
The 2 different names, acetyl and acetone. For like a class that we're always talked about putting everything in alphabetical order.
Oh, yeah.
We switched to it for that.
Yeah, and it's because the acetone is almost treated like that's the name, what you're building the name off of, and the acetyl group is something just randomly attached to it or something. That's why it's opposite what you think. All right, and then all we're going to do today is ketones, and wherever we finish, we're done for the day because I don't want to keep dumping too much on you. And I realize that I need to put an example in here for you for naming IUPAC since I don't give you that option. Okay. If you're going to name something in IUPAC, it's the same process that you're used to. Find the functional group. Ta-da! Find the parent hydrocarbon. Ta-da! And this is a ketone because you have carbon group attached to either side of the carbonyl carbon. So the ending for ketone, since you might not have this memorized yet, is "-one" in IUPAC. So you'd write it in the order of substituents. I didn't put one in this, any examples of substituents in this particular example we're working, but then you would have pentane, and the functional group ending is "-one", and you drop the E so that you don't have two vowels together. This is where it really, really works for you if you're doing the traditional IUPAC system instead of calling it a carboxylic acid derivative in the first place. So
it'd be pentanone.
pentanone. Then you say if you have more than one, for instance, this acetylacetone, you'd put dione, because you can say if there's more than one of a particular functional group as well. Then, step 4, say where everything's located. There are multiple places this ketone could be, so you want to make sure everybody knows that it's on carbon 2, and that's just the IUPAC system. Pretty much what you've been doing before, you just have to learn a new functional group ending. Okay, but common name, they had to come up with 2 different ways you can do this. And that's why I'm saying we're entering the dark recesses of common name, because aldehydes and ketones, they've got multiple things that you can do. The first way of naming it is actually my favorite way to name ketones, even more favorite than IUPAC, because in the derived name system, the carbonyl carbon even becomes part of the functional group, and that's just a ketone right there. And then that's the basis for your name. Just like last semester, if you had an alcohol group or something, that went at the end. And so you would have ethyl alcohol or whatever. And then, just like true common name, you say what carbon groups are attached. And you put them in alphabetical order. So that's ethyl methyl ketone. If you go out to Lowe's and look in the paint thinners and solvents and all of that section where they have all the acetone and everything, they sell MEK. That's ethyl methyl ketone. They just didn't bother to alphabetize it. And that's not just Lowe's. That's just MEK is just, yeah, they goofed up the alphabetization, I guess, because it's easier for everybody to remember, but that's a sort of example of common name for a ketone. Okay, so that's usually referred to as a derived name for common name. I don't know why, but you highlight the carbonyl group. And you name it as a ketone. That's what the ketone ending means in that. And then, ketone. And then put what's attached to it in alphabetical order as though they're substituents. So just in case this question's starting to bubble around in your mind of how am I going to know which way you want me to name a molecule for a test, I put answer blanks that correspond to different ways of naming things for that, so you don't have to guess. All right, and then lastly, for common name of ketones, there's the, I don't know what it's called. I call it the O phenone method, just because that's the ending for it, and I have no other guess of how to describe this as a common name method. You're going to use this only if you see a benzene ring there. That. Which is sometimes called a phenyl group. And I think that that's how you get this ending, because you have phen for phenyl, and then you have one for ketone, and then you have the O in there as an exclamation of surprise, like, oh, phenones. Ugh.
That's a pretty good description.
So with that method, you just have, you note that that's a ketone. Whoops, I should do this as, you're noting that it's a ketone, and only the oxygen is part of the functional group. So that's one thing that makes it different from the derived or the IUPAC.
Is there something that like structured makes it O-phenone, or is it just
Yeah.
named it Bob, so it's Bob?
Yeah, so you have to have a ketone, so you have carbons on either side.
Okay.
And one of those carbons has to be part of a benzene ring.
Gotcha.
All right, so off of that, you know how in common name, you're naming things as though they're carboxylic acid derivatives. And so you would note that that's got 2 carbons in it, and so that makes it acetic acid. And then you're saying, oh, there's that phenyl group there too. So it's based on acetic, but then you're going, oh, it's a phenone. So it's an acetophenone. Just to compare and contrast, if you were doing that as a derived name, then you're including that carbon as your ketone functional group that you're basing the name off of. So I should do that a different color. I've got to process things still, I guess. And then you say what's attached to it. You have a methyl group here, and you have a phenyl group here, and you put them in alphabetical order.
So you have to so derived, if you were to ask for the derived version of it, or the O-phenone, are those 2 different versions of it? Okay.
Yeah, see how the name came out different? Because
Yeah.
you're treating things differently. So with the O-phenone, you've got a carboxylic acid derivative you're basing it off of. With the derived, you're looking at the carbon double bond oxygen, the carbonyl group, as the basis. Did you have a question?
Yeah, so those are both
common name.
Yep,
And there's an IUPAC name.
yep.
Is that phenyl spelled right, or did you leave the L off? Methylphenny, or is it phenyl?
Thank you. Bad things happen when I talk and write at the same time.
So wait, so these are both common name?
Yeah. That's what I'm saying. And then see how nitriles, we're going to do 2 methods with common name and 1 with IUPAC. And then we've got aldehydes are the same thing. I didn't put in here. Yeah, so that's why I've been kind of like holding off with this, because it's like, how many more rules are you going to show me? Why can't we just all get together and settle on one? Yeah. All right, I think you've had plenty to digest. Bite-sized pieces. We'll do a few more rules tomorrow. I'll practice in the meantime. It looks overwhelming now, but once you practice a little bit, you'll get it.